We've been talking a lot about how to identify whether there is a predictive relationship between variables. Specifically, we've been talking about categorical variables. And in this video, we're going to talk about how to produce plots in R in order to help us assess whether two variables are related. So the main learning objective is developing some ease, comfort, confidence, creating these plots. So just to briefly remind you again, the steps we're going to go through in order to assess this relationship are going to be just to first create plots that look like the one below. This corresponds to the kind of second representation that we talked about in the last video. And there are just a few things to keep in mind, really. First, for most of the predictive questions that we're asking about, there's going to be some variable that we're interested in predicting. So in the last example, we were interested in predicting whether or not someone had a close friend to talk to. And when we're setting up these plots, we want to make sure that that variable that we're trying to predict is on the y-axis. And then the variable that we're using to predict is on the x-axis. So in that last example, the idea was if we know someone's gender, then can we predict whether they have a close friend to talk to. So here we're using gender to predict friendship. So once we've got the axes sorted out, then the only thing that we're looking for is whether there is a difference in the distribution of these variables. And the way to tell is by looking at these vertical breaks. So in order to get into R and kind of do another example, let's start with kind of the boilerplate that we should be in the habit of creating for most of our scripts. So I'm going to start by writing the purpose is going to be to investigate the relationships between categorical variables. And the date is July 18th, 2013. And the author, I am Mark Patterson. So first, we're going to load the data. And again, we're going to use this VGAM data library. And we're again going to use the xs.nz dataset. And then we're going to bring up the documentation again, and there are just a few variables that we're going to be really interested in examining. So a lot of this data set is about mental health variables. And so in particular, we're going to say variables of interest are going to be, there's a variable called worry here, which asks people whether they worry that awful things might happen. And then there's another variable called nervous, which is about whether people self-identify as being a nervous person. There's a variable about depression called depress, and then another called cat, which is about whether or not people own a cat. So now we can go ahead and visualize the data. So let's first ask the question, does self-identifying as a nervous person predict worrying? So in particular, we're going to ask whether knowing the value of this nervous variable allows us to predict whether or not someone worries a lot. So now, because these are both categorical variables, we can go ahead and use the plot table approach, and we're going to first list the variable that we want on the x-axis. Now, because we're trying to use this nervous variable to predict, we're going to put that on the x-axis. So here I'm going to list it first and then a comma, and then the variable that I'm going to use on the y-axis, which is called worry. So here, when I go ahead and plot this, This is a little bit difficult to read without axis labels, which I really should add. xlab equals nervous, and the y label is worry. So when I add those here, I see that people who are nervous, so those are the folks over here in these rectangles, are actually much more likely to be worriers, because this rectangle is much taller than this rectangle right here. So from this plot, I can conclude that, yes, in fact, the variable nervous does predict the variable worry. So as another example, we might ask, does owning a cat predict depression? And so here we can, again, because we're focusing on categorical variables, both these this variable depress and the variable cat are just coded on a 0-1 scale. 1 if you're depressed, 1 if you're a cat owner. We can again use this plot table approach. So I'm going to say plot table xs.nz, and then because I'm interested in using cat as the predictive variable, I'm going to put that on the x-axis first, and then a comma, and then I'm going to call the second variable, and I'm going to go ahead and add axis labels as well to keep these straight. So I'm going to say cat ownership here, and my y label is going to be depressed. So here, when I go ahead and plot these variables, this looks like an example where, in fact, cat ownership does not predict depression. Now, the reason that I'm coming to that conclusion is that when I look at folks that do not own cats, it seems as though they're self-reporting being depressed at essentially the exact same rate as people who are cat owners. Now, it's possible that there's a very slight difference here, and we're going to get into a lot more detail on being careful about the conditions under which we say that there is not a predictive relationship. But at least at first brush, it looks like there's really not a predictive relationship here. So returning again to kind of the learning objectives of this lecture, we're really interested in developing the ability to create plots like this one. And here, remember, you just need to be really careful about setting up the axes and then using these lines in order to look for differences in the distribution of these variables.